For 250 years now, humans have been burning coal, oil and gas for energy. Fossil energy sources are in fact prehistoric woods. Millions of years of stored solar energy. The exploitation of fossil fuels made the Industrial Revolution possible and has been providing us with continuous economic growth and technological progress. Yet this development has been causing threatening changes to our climate, the massive effects of which we are only just beginning to experience. By burning coal, oil or gas, carbon dioxide, also known as CO2, is released into the atmosphere. To this day, CO2 emissions have been increasing dramatically. This is because, up until now, economic growth has also meant increasing use of fossil fuels. In just 250 years, a very short time span compared to the Earth's history, humans have increased the quantity of CO2 in the atmosphere by around 40%. This is an alarming amount, bringing us to levels last seen on Earth 4 million years ago. The consequence is increasing warming of the Earth's atmosphere. Since 1750, the temperature on Earth has increased on average by 1 degree Celsius. If we continue like this, the CO2 content of the atmosphere will double, if not triple, in the next 100 years. The Earth will then heat up by a further 3 to 4 degrees. In order to stop this, mankind must put an end to releasing CO2 and other heat-trapping gases. CO2 accumulates in the atmosphere. This means the quicker we stop emitting CO2, the lower the future warming will be. If we do not act, there will be grave consequences. Already today, we are observing global effects such as shifting vegetation zones, rising sea levels, and extending periods of changing weather. Should climate change proceed unabated, it could lead to heavy economic losses, social upheaval, and migration of people across the world. We are facing a global challenge. All countries have the responsibility to reduce their CO2 emissions. Worldwide climate policy is crucial, and not just a matter for industrialized countries. Nevertheless, the US, China and Europe, currently the biggest emitters of CO2 in the world, must lead by example. The 2015 UN Climate Conference in Paris was a breakthrough in international climate policy. 195 states committed themselves to protecting the climate and to reducing emissions step by step. The goal of the agreement reached in Paris is an emission-free society. In Paris, it was agreed to keep global warming to well below 2 degrees Celsius. This means that humankind has less than half of the amount of CO2 left to release compared to the amount it already put into the atmosphere. Our emissions budget is limited. The Paris Agreement commits industrialized countries to help developing countries to reduce their emissions and to adapt to climate change. Good climate policy making means striking a balance between competing interests, acting cooperatively, and sharing innovative concepts and ideas. The Paris Agreement can only be successful if it creates incentives for countries to commit ambitious action rather than wait for others to act. This is why some countries must lead in ambition and implementation. Germany and the European Union aim to be leaders by example. "76% of all greenhouse gases stem from energy production and use. That's why the use of fossil fuels, especially coal combustion, must be reduced as soon as possible. This means not only to shift to renewable energy sources, but also that residual emissions from agriculture, heavy industry, aviation and shipping need to be neutralized in the long term. Germany and the European Union play an important role in global climate protection. The EU is the third largest producer of greenhouse gases after China and the US, and it is responsible for 10% of global greenhouse gas emissions. 1/5 of EU-wide emissions come from Germany. The EU has committed to a 40% reduction in its emissions by 2030, compared to 1990 levels. Germany wants to achieve this goal as early as 2020. The Energiewende, the transition to low-carbon energy supply in Germany, is a technological, political and societal project. If successful, it will be a role model for other regions. However, there is a risk of Germany missing its 2020 emissions goal. Its dependence on coal power has barely been reduced over the last 10 years. In order for the Energiewende to show the way forward in climate protection, abandoning coal as a power source is among the most important steps to be taken. We know we need to act decisively now. The Paris Agreement provides a foundation to build on, and yet agreements mean nothing until they are acted upon. For this, we need creativity, bright ideas, courage, and leadership. International climate policy can only provide the conditions and objectives, but it is up to us to take action, and the time to act is now.
Hi, this is Bill Putman. I'm a climate scientist at NASA's Goddard Space Flight Center. What you're looking at is a supercomputer model of carbon dioxide levels in the Earth's atmosphere. The visualization compresses 1 year of data into a few minutes. Carbon dioxide is the most important greenhouse gas affected by human activity. About half of the carbon dioxide emitted from fossil fuel combustion remains in the atmosphere, while the other half is absorbed by natural land and ocean reservoirs. In the Northern Hemisphere, we see the highest concentrations are focused around major emission sources over North America, Europe, and Asia. Notice how the gas doesn't stay in one place. The dispersion of carbon dioxide is controlled by the large-scale weather patterns within the global circulation. During spring and summer in the Northern Hemisphere, plants absorb a substantial amount of carbon dioxide through photosynthesis, thus removing some of the gas from the atmosphere. We see this change in the model as the red and purple colors start to fade. Meanwhile, in the Southern Hemisphere, we see the release of another pollutant, carbon monoxide. This is a gas that's both harmful to the environment and to humans. During the summer months, plumes of carbon monoxide stream from fires in Africa, South America, and Australia, contributing to high concentrations in the atmosphere. Notice how these emissions are also transported by winds to other parts of the world. As summer transitions to fall and plant photosynthesis decreases, carbon dioxide begins to accumulate in the atmosphere. Although this change is expected, we're seeing higher concentrations of carbon dioxide accumulate in the atmosphere each year. This is contributing to the long-term trend of rising global temperatures. The Orbiting Carbon Observatory 2, or OCO2, will be the first NASA satellite mission to provide a global view of carbon dioxide. OCO2 observations and atmospheric models like GEOS 5 will work closely together to better understand both human emissions and natural fluxes of carbon dioxide. This will help guide climate models toward more reliable predictions of future conditions across the globe.
Air pollution consists of chemicals or particles in the atmosphere that pose serious health and environmental threats. But what causes air pollution, and what does it mean for our planet? Some air pollution comes from natural sources like volcanic eruptions, wildfires, or allergens. But most air pollution results from human activities, such as energy use and agriculture. There are different types of human-made air pollution. When we burn fossil fuels to produce energy, they release greenhouse gases into the air. These emissions, such as carbon dioxide, methane, nitrous oxide, and fluorinated gases, trap heat from the sun in Earth's atmosphere, leading to a rise in global temperatures. This creates a cycle where air pollution contributes to climate change, and climate change creates higher temperatures. In turn, higher temperatures intensify some types of air pollution. For example, climate change increases smog because it forms in the presence of high heat and increased levels of ultraviolet radiation. More frequent extreme weather, such as flooding, contributes to damp conditions and therefore to a rise in mold. Warmer weather also leads to longer pollen seasons and therefore more pollen production. Smog is a type of air pollution that reduces visibility and has serious health effects. Smog can be divided into two categories: sulfurous and photochemical. Sulfurous smog is made up of chemical compounds called sulfur oxides. It occurs when burning sulfur-bearing fossil fuels such as coal. Photochemical smog, also called ground-level ozone, is a result of the reaction between sunlight, nitrogen oxides, and volatile organic compounds. Nitrogen oxides come from car exhaust, coal power plants, and factory emissions. Volatile organic compounds are released from gasoline, paints, and many cleaning solvents. Smog not only creates a brown haze that reduces visibility, but also harms plants, irritates the eyes, and causes respiratory distress. Another category of air pollution is toxic pollutants. These are chemicals such as mercury, lead, dioxins, and benzene that are released during gas or coal combustion, waste incineration, or burning of gasoline. In addition to adverse environmental effects, toxic air pollution can cause serious health problems such as cancer, reproductive complications, and birth defects. While air pollution has many consequences for our planet, there are solutions. We can limit toxic pollutants, smog, and greenhouse gases by decreasing the use of fossil fuels, such as in transportation, manufacturing, and electricity generation. Reducing air pollution not only contributes to a cleaner environment and better human health, but can also slow the rate of global warming.